We've talked about different runoff generation mechanisms that take precipitation that falls from the sky and provide it to the channel network to become stream flow. Let's now look at what some of these different runoff generation mechanisms look like in a plotting space that describes the stream flow as a function of time, and talk about some of the key metrics that we might use to describe certain storm events. So if we were to draw a plot where on the x-axis we have time, and on the y-axis we'll do a shared y-axis. We'll have one plot of runoff as a function of time on the bottom, and then on the top we'll also have rainfall. We can consider the stream flow that's coming in before a particular storm event, and it might be slowly decreasing with time. When there's stream flow and there's no rain, and it hasn't rained in a while, and there hasn't been snow melt in a while, we call this base flow. And base flow is water arriving in the stream from groundwater during periods without rain. So this is sort of like the background flow. Let's say that it then begins raining, and I'll plot this on a reversed y-axis. So we've got some rain coming in here. It's measured maybe in hour increments. And this is one rain event that will produce one runoff event. And hydrologists have a pattern of calling these storm events, and it's a little bit different from the common conception of a storm, which you might think of this big, windy, wild weather event. A storm event for a hydrologist is just a period of rain in most cases. So this is the time that the rainfall starts. So start of rain. And you'll notice that I've still got the base flow declining. So even though it started to rain, the stream has not responded yet at the measurement point at which we're making our measurement. After a certain point of time, though, you see that the stream rapidly rises in flow. So let's see how I want to draw this here. It's rapidly rising, and it reaches some peak. So this is the peak runoff. And we can describe a couple of different lag periods. We can describe one which is the time from the centroid of the rain event. So let's say that that's the average. So this is the centroid, or the center of mass of the rain event. We could also describe it here from the peak rain. And we could describe these different lags. So this would be a lag to peak. From peak to peak, this is a time, a response time of the stream to this event. And here you might have another lag to peak period, which is the centroid of the rain, the average. Like if you flip this over, it would balance on your finger to the peak here. This part of the hydrograph is called, when it's coming up, is called the rising limb. And it's followed after the rain event by kind of a slow, gradual decline, which is known as the falling limb. And this is also known as stream flow recession. There's another lag event that you could describe, which is the time for the start of rain to the initial response. So you can see there's all sorts of metrics. The point is that if you were to compare different runoff generation mechanisms, so same plotting space, you might find some are super flashy, like Hortonian overland flow. And in contrast, others have a much more delayed response and a much more muted hydrograph. So they're not even your stream flow is not going to get to the same peak. So this one might be one of the subsurface groundwater flow runoff generation mechanisms, for example. The one other point that I want to make about these hydrographs is that even though a certain amount of rain comes in, and that causes a certain amount of flow in the stream, we've learned in catchment hydrology, with the help of stable isotope tracers and other passive tracers, that this water that's leaving in the stream is usually not composed, it's not the same water that fell from the sky. It's usually older water that was in storage within the catchment. And a fairly small fraction of the water that's in this particular event hydrograph is new water from that particular storm event.